given marginal revenue function MR equal to 20 e to the power minus x by 10 into 1 minus x by 10, given marginal revenue as 20 e power minus x by 10 into 1 minus x by 10, find the corresponding demand function. Find demand function. We need to find the demand function. First we should calculate revenue. Revenue equal to integral mr into dx plus constant of integration k. Substituting mr here, r of x is equal to revenue r of x is equal to integral 20 e to the power minus x by 10 into 1 minus x by 10 into dx plus constant of integration k. So integrate this by use of isolate. This is used to integrate by integration by parts. By use of isolate, given priority to inverse logarithmic algebraic, we have algebraic term here. This is exponential term, so exponential come at the last, so it has last priority, but 1 minus x by 10 has the priority prior than exponential function. So given u is 1 minus x by 10 and then remaining is the 20 is taken out as constant and the remaining e power minus x by 10 is taken as dv. So totally this is considered as integral u dv, and one part is taken as u, the remaining part is taken as dv. So I have chosen 1 minus x by 10 as u, so the remaining term e power minus x by 10 is taken as dv, u dv, this is dv, and the 20 constant is taken out. So we have only 20 into e to the power minus x by 10, 1 minus x by 10 into dx. In this case, this is taken as u, and the remaining part e power minus x by 10 into dx are taken as dv. So I am writing here the dv is dv equal to e power minus x by 10 into dx. Now integrating dv, we will get v equal to e power minus ax, integral e power minus ax is equal to dx is equal to e power minus ax divided by minus a plus c. By use of it, e power minus x by 10 divided by minus 1 by 10, it will be equal to minus 10 e to the power minus x by 10. And then u dash is equal to 0 minus 1 by 10 equal to minus 1 by 10. I am calculating u dash here. Then applying u double dash, this is a constant becomes 0, and we need a v1 here. Integrating again the function v, will get minus 10 into again e power minus x by 10 turn as e power minus x by 10 by minus 1 by 10. Integrating this e power v1, v2, v3 etc. are successive integrals. U dash, u double dash etc. are successive derivatives. Here we have continuous integrals. So integrating again v will get minus 10 into integral of e power minus x by 10 by use of this formula again e power minus x by 10 divided by minus 1 by 10. Then again reciprocating this, it will be equal to minus 1 by 10 into minus 10, 10 into 10 100, minus minus become plus 100 into e to the power minus x by 10. So this is v1. U double dash 0, so we need not to find v2 here, because in the formula we have, so by Bernoulli formula, integral u dv equal to uv minus u dash v1 plus u double dash v2 minus etc. So u double dash becomes 0, we need not to find the other terms. So applying u dash v1 in the formula, will get r of x is equal to the required revenue function r of x is equal to 20 is taken out constant 20 into, now applying formula uv u is 1 minus x by 10, v is minus 10 into e power minus x by 10, so minus 10 e power minus x by 10 into 1 minus x by 10 uv, then minus u dash into v1, u dash is minus 1 by 10, in formula we have minus of minus 1 by 10 u dash into v1, v1 is 100 into e power minus x by 10 plus constant of integration k, plus constant of integration k applied here. This is very simple thing. First of all, choose u and then choose dv, integrate dv, you will get v, again integrate v, you will get v1. From u differentiate twice, first derivative you will get u dash is minus 1 by 10, again differentiating this, it will be totally constant, becomes 0, so u double dash is 0. So we have derived the required terms here. So substituting in it, integral u dv equal to uv minus integral uv minus u dash v1 plus u double dash vt etc. U double dash becomes 0. We have only two terms. Substituting here, taken 20 as common out, then remaining is integral x e power minus x by 10 1 minus x by 10 dx plus k. This is by the formula uv minus u dash v1 plus constant of integration k. Now we can take out the constant term e power minus x by 10 out, and here we can simplify 10 and 100 by 10 times, and look here, in both the terms we have minus 10 into e power minus x by 10 as common, that is taken out, that is equal to 20 into the common term is taken out, the common term is minus 10 e power minus x by 10 minus 10 e power minus, so minus 10 e to the power minus x by 10 is common to both the terms, that is taken out. The remaining is, the first term we have 1 minus x by 10, this one is remaining, and the second term we have minus 1 only, we have minus 1, in the second term we have minus 1, that is the remaining term after taking out a minus 10 e power minus x by 10, minus 10 e power minus x totally is taken out, the only minus 1 remains here. When we take out a minus 10 took out minus 10 e power minus x by 10 in this, we have 1 minus x by 10 as remaining. Now cancelling these two, the remaining is 20 into minus 10 e power minus x by 10 into minus x by 10 plus constant of integration k. Again we can cancel the minus 10 and minus 10, we'll get minus 10 and minus 10, it will be 20 x into e power minus x by 10 plus constant of integration k. This is the revenue function r. So now we need the demand function, and also we have this is r revenue. When r equal to 0, x is equal to 0, which implies when r equal to 0, x is equal to 0, substituting in it, 0 equal to x 0 means the total term becomes 0, and 0 plus k, which implies k equal to 0. Therefore substituting k equal to 0 in the above, will get the revenue function r equal to therefore revenue r equal to, because k becomes 0 when r 0 x 0, so substituting k equal to 0 in 1 implies r equal to 20 x into e power minus x by 10, 20 x into e power minus x by 10 plus constant k becomes 0. Now we need the demand function, demand p equal to revenue by x, r divided by x. So dividing it by x, x get cancelled, remaining is 20 e power minus x by 10, remaining is 20 e to the power minus x by 10 is the demand function.